Brandon Thacker. I work for Electric Line. We build, like I said, the full power lines and the substations for the mines. Now we're getting into solar.
Hello, I'm Matthew Gilliam, owner of Gilliam Solar, an exploratory company here in the coal fields of West Virginia. I'm a third-generation electrician here in coal country. We are not in any competition against coal, but we are looking towards the future. We are currently doing our first project here at the Smart Office in Williamson, West Virginia.
West Virginia has always been an energy leader. We anticipate that we will create a greater diversified energy portfolio and continue to be an energy leader. And in providing that to the nation and the country, our valuable resources and blood, sweat, tears, and labor to help build America, and we want to continue to fulfill that civic need as well as maintain a certain quality of life within our community. Because we are in this coal region limited with the number of job opportunities, we see this as a way to re-educate and retrain skilled labor.
The Industrial Revolution was built on the backs of the men that mine coal here. That energy that helped drive the Industrial Revolution, we see the opportunities before us to transition to new energy, so we have a new energy revolution.
Hi, my name is Eric Mathis. I'm going to unpack two specific terms for you: applied sustainability and energy optimization. First, the relationship is how applied sustainability relates to energy optimization. And it's as simple as this: utilizing fossil fuel resources today to build renewable energy resources for tomorrow. Concerning energy optimization, this specifically means moving away from an either-or strategy where politicians choose the winners and losers to an all-the-above strategy, essentially unleashing the optimizing dynamics of the free market. As a part of Sustainable Williamson's energy optimization program, we are presently integrating demand control technologies into several city buildings, including the Smart Office. This is a part of Sustainable Williamson's larger goal of becoming a virtual power plant, or a microgrid, that is directly linked to our integrated energy parks.
Hi, my name is Tom Worledge. I'm the architect for the Smart Office. As soon as you walk in the front door, you will be facing an energy dashboard. That dashboard monitors the building's energy use and water use. This not only provides energy data on the building itself, on the Smart Office itself, but we're hoping to have a component of that same dashboard that allows you to see how much energy the community is using as a whole.
Welcome to our solar system that we just installed for our Smart Office.
I'm Jamie Trowbridge. I'm a grad student at Appalachian State University. I designed this system, like seeing real solar on top of a real building in southern West Virginia is really exciting.
My name's Rob Taylor. I'm a solar installation supervisor in California with a nonprofit solar installer, and my job is to show all the volunteers how to install solar and maintain a quality installation and a safe installation.
What we've got here is approximately 3 kilowatt solar array we're putting together, and this solar array is going to directly power the Sustainable Williamson Smart Office downstairs. This is the inverter we're using right here. It's a micro inverter. A lot of systems you'll see typically all the modules up here on the roof will all just plug into each other and run down to a central inverter. But in this system we're doing, each individual module is going to run to its own inverter, right? So this is our Envoy. This is the monitoring system for the in-phase microinverters. Basically what it tells us on here, it'll tell us on the far right here, it'll tell us the number of inverters it's recognizing. In the middle, it'll show us the instantaneous watts that the array is making, and it'll shuffle between that and kilowatt hours, the cumulative amount of power that it's made since you turned it on. Once we get this thing all up and running, we're going to hardwire this monitoring to an internet router, and that way we can spool all this information onto a web page. So if you're across the country, if you're on vacation, you can pull it up on your smartphone and bring up a map of this array right here and see each individual inverter, how much power it's putting out right now and how much it's put out all week and since we turned it on the first time.
I'm Roger Ford. I'm CEO of Patriot Bioenergy. Patriot Bioenergy Corporation is a alternative energy company that has been looking at how we integrate in a mix the fossil fuels that are abundant in Central Appalachia. Our background has focused on the creation of an energy park model that looks at a regional approach to energy generation and fuel production. Also, as part of that, our goal is to look at a post-mining land use that is practical in that we would construct a couple of power generation facilities using renewable solar power, natural gas, and biomass in a configuration to generate electricity.
The integrated energy parks will be developed on both active and reclaimed mine lands. These parks will integrate utility-scale natural gas, solar, and biomass. The biomass component will utilize sustainably harvested feedstocks for producing electricity. And it is important to note that a portion of the overall revenues that is generated by the integrated energy parks will be used to reforest mine-scarred lands throughout Central Appalachia. As a part of our integrated energy parks, we are developing a newly emerging technology called pyrolysis. What this looks like in the coal fields is first we will grow forest on mine-scarred lands utilizing the forest reclamation approach. We'll then harvest some of those hardwoods and process it through the pyrolysis facility. This will produce electricity and biochar, and then we'll use the biochar to rebuild soils.
Okay, I'm Chris Fields Johnson. I'm a graduate student at Virginia Tech, and I work in the Crop and Soil Environmental Sciences Department. The last few years I've been working with reforestation of mine sites. So today we're talking about reclaiming mine lands and soil development and forest development. Right now we're on a site that's more typical of the post-SMACRA era, but before the ARI and the forestry reclamation approach came along, where they would overly compact sites and plant competitive grasses and things, and it led to a stagnation of succession. It's really hard for the native forest, which isn't too far away here, to invade this site and to reclaim it for itself. There's a million acres or so of land in the Appalachians that are in this kind of condition, and what we want to do now with the forestry reclamation approach is avoid this, and you find better ways of doing things so you can immediately go into a really productive forest. This is a soil pit that was dug into the ground a few years ago to kind of demonstrate, figure out what's going on with soil development. And again, this is the Taggart bench, so they pushed out the crushed rock in this direction and laid it on top of the existing ground. After a little less than 30 years of soil development, you can clearly see a really well-developed A horizon above this point. See how dark that is? Okay, we're at the Virginia Tech University greenhouses. We've got some experiments going on inside, looking at biochar application to mine spoils. And we've got some black locusts and sycamores growing and looking at different rates of char application. And we've even got some trees growing in pure biochar. So come on in, we'll take a look at that. So this tree was this tall right here at the beginning of the growing season. And now, I don't know, but it's about 4 times that height. So it's putting on an incredible amount of biomass. So we know a few things from this. One, the biochar isn't toxic to the trees because obviously they're doing well in it. And it's supporting pretty rapid growth. So if that's true, you could just pile up biochar and let it weather for a few months in the rain and then plant trees into it.